Welcome. In this video, we are going to discuss about MRI, magnetic resonance imaging. Raman Damadia, a physician, is called a father of MRI. MRI makes use of the magnetic properties of the atomic nuclei. Hydrogen nucleus, we know that hydrogen nucleus has a single proton. So usually the hydrogen atoms are present in water molecules. So our human body is made up of water molecules. 70% of the human body is made up of water molecules. So all water molecules will definitely consist of the hydrogen atoms. Based on this hydrogen atoms, only this MRI imaging is working. The hydrogen nuclei partially aligned by a strong magnetic field in the scanner. The nuclei can be rotated using radio waves and they subsequently oscillate in the magnetic field while returning to equilibrium. Simultaneously, they emit a radio signal. This is detected using the antennas and very detailed image can be made of soft tissues. MRI. Usually the MRI system, so this is a typical model of the MRI system. So this is called a patient lying board, or we used to call this as a bore, okay, patient table. So where the patient is lying down on the patient table. The MRI system consists of magnet. It is made up of, the MRI system is made up of the magnet. So the biggest and the most important component of an MRI system is the magnet. And there is a horizontal tube where the patient enters or running through the magnet. So we also call this as bore. Usually this magnet strength they are maintaining in the MRI system is in the range of 1.5 to 7 Tesla. We can compare this with the Earth magnetic field. So there it is only 0.5 Gauss. You just compare how huge it is. It is 1.5 to 7 Tesla they are maintaining in the MRI systems. Most MRI systems uses superconducting magnet. Superconducting magnet, which consists of many coils through which a current is passed, creating a magnetic field. The magnetic field is around nearly 2 Tesla. So this allows the highest quality of imaging. Superconducting magnets, it is used in order to bring the highest quality of imaging. There are other magnets like 3 gradient magnets or inside the MRI machine. So gradient magnets, Y coil, Z coil and X coil, 3 gradient magnets. These magnets are much lower strength when compared to the main magnetic field. Main magnet creates an intense stable magnetic field around the patient. The gradient magnets are used to create a variable field which allows different parts of the body to be scanned. So another part of the MRI system is a set of coils. Another part of the MRI system is a set of coils that transmit radio frequency waves into the patient body. So there are different types of RF coils as designed for different parts of the body like knees, shoulders, wrists, heads, etc. The RF coils, radio frequency coils. The RF coils are used here. Look at this picture. So generally in our human body is made up of water molecules. In water molecules, the hydrogen atoms are present. Usually, the hydrogen atoms, look at the first picture, the hydrogen atoms are randomly arranged. So, the atoms spins in random directions like tops around their individual magnetic field. We all know how the tops is spinning. Like that, the hydrogen atoms are randomly arranged. The magnetic field produced by the MRI atoms line up either north or south. Once we give the magnetic field, after the strong magnetic field, look at the second picture. So, the atoms will line up either north or south. But there are few unmatched atoms will be there. So, it won't align in any directions. There will be a few unmatched atoms. When the radio frequency pulse is applied, the unmatched atoms spin the other way. When the radio frequency is turned off, the extra unmatched atoms return to the normal position, emitting some energy. This energy sends a signal to the computer, and the computer uses the mathematical formula to convert the signals into an image. So, the main parts are the main magnetic field, it is produced by the superconducting magnet, and the gradient magnets are used to produce variable magnetic field, okay, but the strength is comparatively low when compared to the main magnet, and this is in order to select the location where we have to take the scan particularly. For example, for hand, leg, or for stomach, okay, MRI is used to take the imaging of the soft tissues also. And then we need a radio frequency coils, RF coils, in order to generate the radio frequency pulses. This radio frequency pulses is used to applied for the unmatched atoms to spin there in the another way, okay. And when the radio frequency is turned off, the extra atoms return to the normal position, and this will emit an energy, and this energy is sent to the computer as a signal, and there it is used to create the image. So, this is the working of MRI system. So, Lamar frequency, so it is called as a resonant frequency. It is calculated based on the particular tissue being imaged and the strength of the main magnetic field. So, you can look at the picture, the whole MRI equipment. So, in green color it is indicating the arrow where the bore, the patient can be lie down on that, and they will be moved inside and outside of the MRI magnetic systems, and there will be a main magnet. So, here it is maintained as 4T magnet, it is 4 Tesla, the strength of the magnet, and there will be gradient magnets also available, gradient coils, magnetic coils also available in order to select the location, and RF coil, radio frequency coil, it is used to align the atoms. So, this is all about the MRI scanning, magnetic resonance imaging scanning. But this magnetic resonance imaging scanning is used for diagnostic of all parts of the human body. So, it can also even scan the soft tissues, because here the image is generally based on the hydrogen atoms. Thank you.